This is the Smart Outlet by David Maier and Rios. Our project consists of two different compartments. The small box contains components that connect to the main line, and the large box contains our other circuitry. On the side, we have a socket which can connect your devices to. Then we have our motion sensor, which detects movement. Lastly, a cord that connects to your home outlet powering the Smart Outlet. To demonstrate all the features of the Smart Outlet, we designed and programmed an app for Android. To start the app, you click the icon on your phone. Then you're able to select to connect to a Bluetooth by pressing the Bluetooth button and then selecting your Bluetooth module. And then you're able to see that you have the ability to turn and off your outlet. So you're able to turn it off, turn it on, whichever you prefer. And then you can also set a date and time to have an automatic shut off. So right now it's 5:35. So right now we're gonna set the time for 5:36, and then we're gonna input the time and date, and then send it to the microcontroller through Bluetooth. And another feature that we have is have a timer that you could put a time up to 59 minutes, and it will also turn off your outlet, and depending on the time you input. And then we also have our motion sensor. So when you select it, and if your outlet is off, as you can see right now, when it turned off with the automatic shut off, you're able to turn it back, select your motion detector, and it'll have a delay where it won't be sensing anything until the person left the room, and then after a certain time, you're able to select it. So it's like sense my hand, it turned on that light.
The last feature that we have on our device is to show the present power consumption. So if we were to click present power consumption button right here, it would show the amount in watts that we are currently consuming, which is close to 0 watts right now with all of our devices. So if I plugged in this light bulb that is rated for close to 70 watts, I have it on dimming capabilities right now. It's showing right now 39 watts, and using the dimmer switch that I have, if I gradually increase the brightness of this, the watts will constantly be increasing as well until it reaches close to what the light is rated for. Now we will move on to the hardware of our project. We will start with the smaller box. The smaller box contains all of our lines that come directly from the main voltage. So if we open up the panel, you can see it has our outlet here. Deep inside, we also have the Hall effect sensor back here. This is measuring all of the current that's going directly into our outlet. Right next to it, we have a relay that takes up to 10 amps. This relay is used whenever we want to turn off the power going directly to the outlet. The second box that we have has the rest of our circuitry. If power were to ever go out at the main line, then this relay right here would switch from the main line to the backup battery. However, when switching, voltage may drop. So in order to keep all of our components powered, we are using many capacitors in parallel to keep this voltage. So demonstrating this now, the light has gone off, however everything is still powered. Some of the other hardware components that we have include another voltage regulator. This is stepping down our 5 volts down to a voltage a little bit below 2 volts. This is what we use to go into our current sensor, the Hall effect sensor, and then we are outputting it to this op amp right here. This op amp is a voltage follower. What this is doing is because we have this circuit here because if we were to connect the Hall effect sensor directly to the microcontroller, there would be a lot of different ripples. However, this voltage follower keeps it at a much more steady rate. Lastly, right down here below, we have a transformer converting 120 volts alternating current down to 9 volts DC. This is what we use to power everything. We're running that through a 5-volt regulator, and this is a much more acceptable voltage to power all of our components.
The last components are the RTC, which is used to keep track of real time on the microcontroller. It constantly checks the automatic shut off and timer when selected to turn off the outlet. The SD card and adapter is used to store the power consumed in time every 5 seconds to memory. The stored information in the SD card can be accessed at a later time by placing the SD card in your phone or computer. The EE175B Bluetooth module is used for the wireless communication between our phone and our microcontroller.